All right, so today we're going to dive into some really cool MIT research.
Oh, this is going to be fun.
Yeah, right. It's about detecting tiny asteroids.
Tiny.
Yeah, like the size of a bus even.
Wow, that's small.
Yeah, and what it means for us, here on Earth.
Right.
This is about, planetary defense.
Right, I see, yeah.
It's not just about, cataloging space rocks.
No, definitely not. It's a much bigger deal than that.
Exactly, yeah.
It really shows, a blind spot that we've had.
Mm-hmm.
These, what are they called? Decameter asteroids.
Decameter
The
asteroids.
10 to 100 meter ones.
Yeah.
They're small enough that they've been, slipping past our detection.
Right.
But they're frequent enough to be a real concern.
Yeah, the article even mentions that they hit Earth every few years.
Like, regularly.
Yeah, pretty much.
Wow.
A bus-sized asteroid hitting Earth. I mean,
Sounds like
a disaster movie or something.
Yeah, right.
But seriously, how much damage can something that size actually do?
Well, a lot, unfortunately.
Oh, no.
Remember back in 2013, the Chelyabinsk meteor?
Yeah, over Russia.
Yeah, that was only about 20 meters across.
Oh, wow.
And the shock wave from its explosion injured over 1,000 people.
You're kidding.
Nope.
So not something to be taken lightly.
Not at all.
Which makes this new detection method even more crucial.
Right. It's super important.
The MIT article calls it shift and stacking.
Shift and stacking.
Yeah. How does that even work?
Okay, so it's a really clever adaptation of a technique that's used to find exoplanets.
Okay.
They're basically combining lots of images from telescopes, right?
Yeah.
To amplify the signal of these really faint, small asteroids,
right,
making them pop out from the background.
It's like finding a hidden treasure in someone else's attic, right?
Yeah, that's a good way to put it.
Yeah, instead of gathering new data, they're finding new ways to analyze what we already have.
Exactly, working smarter, not harder.
I find it amazing that this is letting them spot asteroids far smaller than we could before.
Right, and especially in the main asteroid belt.
Yeah, between Mars and Jupiter.
Yeah.
Wow.
Yeah, so previously, the smallest asteroids we could reliably detect in the main belt were about 1 kilometer wide. This new method is letting us see objects down to just 10 meters across.
So that's
That's 100-fold increase in resolution.
That's mind-blowing.
Yeah, it's incredible.
And they found over 138 of these tiny asteroids already.
I know, it's amazing.
Just by looking at existing data from the James Webb Space Telescope.
Oh, the James Webb.
Yeah.
It's been instrumental in this.
Really?
Yeah, because its ability to observe in infrared wavelengths. That's key here,
Okay.
Because asteroids actually appear brighter in infrared.
Oh, interesting.
Yeah.
So it's like the Webb telescope is giving us a whole new view of the asteroid belt.
Yeah, a totally new perspective.
The researchers are calling this a totally new, unexplored space.
I love that.
Yeah. What makes it so groundbreaking?
Well, I mean, we're not just adding a few more data points.
Right.
We're essentially opening up a whole new population of objects.
Wow.
To study. Think of it like discovering a hidden ecosystem.
Oh, I like that.
That we never knew existed.
Yeah, teeming with life.
Exactly.
So we're not just learning about these individual asteroids.
No.
We're gaining insight into the whole history and dynamics of the asteroid belt itself.
Precisely.
Yeah.
That's amazing. We can start to piece together, how these smaller asteroids formed.
Yeah.
From collisions and breakups of the larger one.
Right.
It's like having a window into the processes that shaped our solar system, billions of years ago.
Wow.
It's pretty amazing.
And speaking of shaping our solar system.
Oh, yeah.
This research has some pretty big implications for planetary defense.
Oh, absolutely.
Early detection of a potential threat.
That's everything.
Is everything, right?
Yeah, the more lead time we have, the better our chances of developing strategies to, to deal with a potential impact.
Okay.
This new method is huge for having a more proactive rather than reactive planetary defense system.
So we're not just passively watching anymore.
Okay.
We're moving towards being able to do something.
Yes, exactly.
About a potential threat.
That's the goal.
But if most of these asteroids are in the main belt, why are we worried about them hitting Earth?
Well, okay, so the main belt, right?
Yeah.
It's kind of like a cosmic shooting gallery.
Oh, interesting.
With asteroids constantly, jostling and colliding.
Okay.
Sometimes those collisions, or gravitational interactions with planets like Jupiter, can fling an asteroid out of its stable orbit.
Sending it careening towards Earth.
Potentially, yes.
Yikes.
Yeah, it's a bit scary.
So this ability to detect even the small ones means we're essentially getting a much better grasp on what's out there and where it's going.
Exactly. It's all about understanding the bigger picture.
And that understanding is key.
It is.
For assessing which asteroids pose a real threat.
Right.
And what we can do about them.
Exactly.
But that brings up some really
very interesting
ethical and practical questions.
Oh, for sure.
Right.
Yeah. Yeah, it's kind of like opening Pandora's box, isn't it?
Oh, how so?
Well, we're getting all this knowledge, right?
Yeah.
And the tools to maybe actually change the course of these, celestial objects.
Right.
That's a huge responsibility.
It's not just the technology either.
No, definitely not.
There's like some serious political and ethical stuff, too.
Oh, absolutely.
That we have to think about.
Yeah, like if we find an asteroid, that's going to hit Earth.
Right, right.
Who decides what we do?
Yeah, that's a great question.
And what happens if, we try to deflect it and it goes wrong?
Ooh.
What are the global implications of that?
That's a big one.
These are questions that, we need everyone to work together on.
Yeah, international cooperation.
Exactly. And we need to, really understand the risks and benefits of anything we might try to do.
It feels like we're entering a whole new era of space exploration.
It does, doesn't it?
Yeah, it's not just observing anymore.
No.
We're actually, shaping the cosmos.
We are, yeah.
That's both exhilarating and kind of daunting.
It's both, for sure.
Yeah, it is.
And it also shows, how amazing humans are. Scientists and engineers are always pushing the limits.
Yeah, that's true. And this discovery is a perfect example of that.
Oh, it really is.
There's a line in the MIT article that really stuck with me.
Oh, yeah.
It says, "This is a totally new, unexplored space we are entering thanks to modern technologies."
I love that line.
Yeah.
What do they mean by that?
I mean, what makes this so groundbreaking?
Well, it shows that it's not just about finding a few more asteroids.
Right.
Yeah. It's about opening up this whole new population of objects that we can study.
Wow.
You can learn about the asteroid belt in a totally different way. How it's changed over time, how it all works.
So these smaller asteroids,
yeah,
they're like the building blocks of the bigger one.
Exactly. They give us clues about what the bigger ones are made of.
Okay.
And how they formed, which helps us understand the early solar system.
Right. And how planets form.
Exactly.
So it's all connected.
Yeah, it's all part of the big picture.
This new method isn't just about planetary defense.
No.
It's about, unlocking secrets of our cosmic origins.
Exactly.
It's really cool.
It is, yeah.
The article also mentioned that one of the newly discovered asteroids might be a Trojan.
Oh, yeah, the Trojans.
For those of us who aren't astronomers, what exactly is a Trojan asteroid?
Okay, so Trojan asteroids are really cool.
Okay.
They share the same orbit as a planet. But they stay in these stable points called Lagrange points.
Lagrange points.
Yeah, they're like where the gravity of the planet and the sun balance out.
So they're kind of like cosmic hitchhikers?
Yeah, that's a great way to put it.
Tagging along with a planet.
Exactly.
It's cool.
Jupiter has, the most Trojan asteroids.
Oh, really?
Yeah, because it's so big and has such strong gravity.
Makes sense.
They're like a mini asteroid belt orbiting along with Jupiter.
Wow, that's wild.
It is.
It's amazing to think this new method is helping us find these tiny asteroids in the main belt.
Yeah.
And it's also shedding light on these Trojan asteroids, too.
It's really powerful.
You mentioned earlier that not all asteroids in the main belt are on a collision course with Earth.
Right.
But some can get nudged out.
Yeah, that's right.
What could cause an asteroid to become a potential threat?
Okay, so there are a few things. One is the gravity of the planets.
Okay.
Especially Jupiter.
Yeah.
It's so massive, it can mess with the orbits of smaller asteroids.
And send them in different directions.
Exactly.
So it's kind of like a cosmic billiards game.
Yeah, kinda.
And then there are collisions between asteroids themselves.
Oh, yeah, for sure.
The asteroid belt is a pretty crowded place.
It is.
So collisions are bound to happen. Yeah. When two asteroids collide, they can break into smaller pieces.
Right.
And some of those pieces can get flung out of the belt.
Exactly. It's a chain reaction.
So one collision can lead to a cascade of events, sending asteroids all over the solar system.
Yeah, which is why early detection is so important.
Absolutely.
We need to know what's coming.
Okay, so we've got gravity from planets.
Yeah.
And collisions between asteroids. What else?
There's another thing called the Yarkovsky effect.
The Yarkovsky effect.
Yeah, it's a bit of a weird one.
What is that?
It's all about how sunlight heats an asteroid.
Okay.
And how that heat is then radiated back into space. This uneven heating and cooling can actually create a tiny thrust.
You're kidding?
No, seriously.
Wow.
And over millions of years, this can actually change the asteroid's orbit.
So even sunlight can affect the paths of asteroids.
It can, yeah. It's pretty amazing.
That is incredible.
It just shows how dynamic the solar system is.
Yeah, for sure.
These aren't just rocks sitting there.
Right.
They're constantly moving and changing.
Wow.
And to predict which ones might come close to Earth, we need to understand all these forces.
Right. The gravitational and the thermal forces?
Exactly.
It sounds like there's a lot more to these space rocks than meets the eye.
Oh, absolutely.
The more we learn, the more fascinating they become.
They really are.
We've covered a lot today.
We have.
This new detection method.
Yeah.
The insights it's giving us into the asteroid belt and Trojan asteroids, and the implications for planetary defense.
It's a lot to take in.
It is.
And we've only just scratched the surface.
That's true.
There's so much more to learn.
But that's the beauty of science, right?
Yeah.
Every answer leads to more questions.
Exactly.
Before we get too carried away.
Okay.
Let's talk about the elephant in the room.
Oh, you mean?
What happens if we do find an asteroid that's going to hit Earth?
Yeah, what do we do then?
What are our options?
That's the big question, isn't it?
That's the big question, right? It's one thing to find them, but what do we actually do about an asteroid heading for Earth?
Well, thankfully, scientists and engineers are working on that,
So what are we talking about here? Like, what are the options?
Well, one idea is a kinetic impactor.
A kinetic what?
Impactor, yeah. It's basically a spacecraft, but it slams into the asteroid really fast.
Oh, okay. So it's like a cosmic billiards shot.
Yeah, exactly. You just nudge it out of the way.
Yep.
Even a small change can make a big difference if you do it early enough.
That makes sense. But what if you need something a little more subtle than a crash?
Well, there's the gravity tractor.
Okay, what's that? A tractor beam?
Not quite, but it uses gravity. So you park a spacecraft near the asteroid and just let its gravity pull the asteroid off course very slowly over time.
So it's super delicate.
Yeah, it would take years to work. It's very precise.
Yeah. Okay, and then there's the one everyone always talks about, nukes in space.
Right, yeah. So that would mean blowing up a nuke near the asteroid to either destroy it or break it into smaller pieces.
That seems pretty risky.
It has a lot of issues, yeah. Ethical stuff, political stuff, and of course, radiation. It's really a last resort.
So it sounds like there's no one perfect answer.
No, not really. The way you would try to stop an asteroid depends on how big it is, what it's made of, how fast it's going, how much time we have. It's different every time.
It's a real challenge then. And like we talked about, there's the political and ethical stuff too.
Oh, yeah, for sure. Like if there's an asteroid coming right for us, who gets to make the call about what we do?
And who is responsible if it goes wrong?
Right. These are really big questions.
It seems like we need a plan for the whole planet,
Absolutely. We need to be ready and know exactly what to do, who talks to who makes the decision, stuff like that. It's all new.
This has been really interesting. It's amazing that we can find these tiny asteroids now and maybe even stop them.
Yeah, and we're just getting started.
But we have a lot to figure out, that's for sure.
Yeah, it's a really fast-moving area of research. We need better technology, and everyone has to work together. But we're making progress, and at least we know about the risks.
So what's the one thing our listeners should take away from all this?
Well, I'd say it's this. We live in a really cool solar system, but it can be a dangerous place too. Most asteroids aren't a problem, but some could be. But the good news is we're learning how to deal with that. So it's a really exciting time for planetary defense.
That's a great point. And hey, maybe one of our listeners will even end up working on this stuff someday. Thanks for joining us on this deep dive into tiny asteroids and planetary defense. Keep looking up, and remember, we're all in this together.